Hello friends, in this video we'll see the topic monotone sequences. First see some definitions. A sequence xn of real numbers is said to be monotonically increasing if xn means nth term of the sequence xn is less than or equal to xn plus 1 means its next term. Any term of the sequence is always less than or equal to its next term, and it should be true for all n. Then the sequence xn is said to be monotonically increasing sequence, means the terms of the sequence are in increasing manner. For example, let's see the sequence. Let xn is equal to n upon n plus 1 for all n belongs to n. Then the terms of the sequence xn are: the first term is 1 by 2, the second term is 2 by 3, next term is 3 by 4, next term is 4 by 5. See, you can note that the terms of the sequence are increasing. 1 by 2 means 0.5, 2 by 3 means 0.6666, 3 by 4 means 0.75, 4 by 5 means 0.8. See, terms of the sequence are increasing. Any term of the sequence is less than or equal to its next term, right? Let's see another example. Let suppose xn is equal to n square for n belongs to n. Then xn is the first term of the sequence xn is 1, second 4, 9, 16, 25. See, the terms of the sequence are increasing, therefore it is monotonically increasing sequence. Okay. That's the definition of monotonically decreasing sequence. Second, a sequence xn of real numbers is said to be monotonically decreasing if xn is greater or equal xn plus 1 for all n belongs to n. Means we have just reverse the inequality. In monotonically increasing xn is less than or equal to xn plus 1. And in monotonically decreasing sequence, we are taking xn is greater or equal xn plus 1. Means any term of the sequence is greater than or equal to its next term. Means the terms of the sequence are in decreasing manner. So for example, let xn is equal to 1 by n for n belongs to n. Then the terms of the sequence xn are 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. You can note that the terms of the sequence are decreasing. First term is 1, second is 0.5, 1 by 2 is 0.5, 1 by 3, 0.333, 1 by 4, 0.25, 1 by 5, 0.2, and so on. The terms of the sequence are decreasing, therefore it is Example of monotonically decreasing sequence. Let's see another example. Let suppose xn is equal to minus n for n belongs to n. Then the terms of the sequences sequence xn are minus 1, minus 2, minus 3, minus 4, minus 5, and so on. You can note that the terms of the sequence are decreasing. Therefore, this is also example of monotonically decreasing sequence of real numbers. Okay. Third definition. And a sequence xn of real numbers is said to be monotone sequence, or it is said to be monotone if it is monotonically increasing or monotonically decreasing. Means the sequence should be monotonically increasing or monotonically decreasing. Then we have to call the sequence as monotone sequence. Okay. Let's see the example of sequence which is not monotone. Example of sequence of real numbers which is not monotone. Let xn is equal to minus 1 raised to n plus 1 divided by n for n belongs to n. See, then the terms of the sequence xn are: first term is 1, second is minus 1 by 2, third term is 1 by 3, minus 1 by 4, 1 by 5, minus 1 by 6, and so on. Let me see, the terms of the sequence are neither increasing nor decreasing. Therefore, this is example of sequence which is not monotone. Actually, there are a lot of sequences which are not monotone. Note that. A constant sequence is both monotonically increasing and monotonically decreasing. Because for example, suppose let xn is equal to suppose c, where c is constant. Where c is a constant real number. Constant real number. Then you can note that xn is less than or equal to xn plus 1 and xn plus 1 or xn is greater or equal xn plus 1 for all n belongs to n, because both xn and xn plus 1 c are c, right? Therefore it is both monotonically increasing and decreasing, and its converse is also true, means a sequence which is both monotonically increasing and monotonically decreasing is constant sequence. Means a sequence which is both monotonically increasing and monotonically decreasing possible only if all terms of the sequence are equal, means it is constant sequence. Okay, let's see note 3. If a sequence xn of real numbers is monotonically increasing, then it is bounded below by its first term, that is x1. Is bounded below by its first term, because since it is monotonic, since xn is monotonically increasing sequence, x1 is less than or equal to x2, x2 is less than or equal to x3, x3 is less than or equal to x4, and so on. Means the terms of the sequence somewhere will get xn, xn is less than or equal to xn plus 1, and so on, right? Means x1 is the smallest term of the sequence, so the terms of the sequence are bounded below by x1. Okay, similar note for monotonically decreasing sequence. If a sequence xn is monotonically decreasing, then it is bounded above by its first term, because see, if sequence xn is monotonically decreasing, then x1 is greater equal x2, x2 is greater equal x3, x3 is greater equal x4. In general, xn is greater equal xn plus 1, and so on. Means you can note that first term of the sequence is greater equal all terms of the sequence. Therefore, the terms of the sequence is bounded above by its first term, that is x1. Note number 5. If a sequence xn is monotonically increasing and bounded above, then you see we have a sequence which is monotonically increasing, means the terms of the sequence are in increasing manner, but and it is bounded above, means there is some real number that uh, such that all terms of the sequence are less than or equal to that real number, right? Means the terms of the sequence are increasing but they cannot be greater than some real number. Therefore the sequence, it is possible only if the sequence is convergent and it converges to the supremum, means least upper bound of the set of all terms of the sequence. Okay. Similar note is for monotonically decreasing sequence. If a sequence xn is monotonically decreasing and bounded below, then it is convergent and it converges to the infimum of, infimum is greatest lower bound of the set xn, so that n belongs to n. You see, suppose we have a monotonically decreasing sequence, means the terms of the sequence are in decreasing manner, but and it is bounded below also, means the terms of the sequence are decreasing but there exists, bounded below means there exists some real number, so that all terms of the sequence are greater equal that real number, means terms of the sequence are decreasing but they cannot be less than or equal to some real number, right? So it is possible only if the sequence is convergent and converges to infimum means greatest lower bound of the set of all terms of the sequence. Okay. You can visualize note number 5 and 6 by taking particular type of examples. Okay. And by combining 5 and 6, note number 5 and 6, we can say that let xn be a sequence of real numbers, then xn is convergent, if xn is convergent sequence of real numbers, if and only if xn is bounded. We already proved that every convergent sequence is bounded, but sequence is bounded sorry, let xn be a monotone. That is important. Monotone sequence of real numbers. See, we know that every convergence sequence is bounded, but if sequence is bounded as well as it is monotone, then it is convergent also. And you can get this using note number 5 and 6. Okay. Okay. I'm stopping the video. Thanks for watching.